Okay, hello all you crazy people out there. My name is Michael. I like wizards and dragons and making games, and let's talk about shader functions. So when dealing with shaders in the past, we've seen functions before. There's a couple of them. If you go into the fragment shader half of a default pass-through shader that you create in GameMaker, you can see one, texture 2D. And this takes some inputs. It takes a sampler and it takes a vector 2, and it looks up the corresponding color on the sampler based on the vector 2 coordinates that you give it. And there are some other functions. There are some basic trigonometry functions like sine and cosine. There are some basic math functions like power, raise a number to a power. You have floor, min, max. Clamp is another fun one, and a bunch of other functions. Dot product, of course, how could I forget that? That's one of my favorites. These are all built into the shader language. They're automatically here. You can just use them. You don't have to do anything special to make them work. You can, of course, define more functions than this. This is where all the code that actually executes in your vertex shader and in your fragment shader is contained. When you run the game, when you set the shader on each vertex and on each fragment, the computer runs this function on them. Functions, of course, as you probably know, are very useful if you want to be able to reuse code without having to repeat your code. A common programming rule of thumb is DRY, which stands for don't repeat yourself. And functions are very helpful when it comes to that. Of course, functions are also quite useful when it comes to things just as simple as code organization. Even if you're not actually repeating any code, it often helps to organize your code into function calls so that the whole thing isn't just like one long monolithic block of code that's hard to read. So let's start out with a basic example. I am going to say vec for color is going to equal the vertex color multiplied by, in the pass-through shader, the result of the texture lookup. And I'm going to add a few empty lines, and then at the bottom of this otherwise default pass-through shader, I'm going to set gl_frag color equal to color. And this is the same thing that we had before. It's just split up over two lines in the fragment shader as opposed to one line. By the way, this project that I'm working out of here is my default base 2D project that I often use to demonstrate shaders and stuff. I've used it in a number of videos so far. It's just a duckling that walks around the screen, and there's a couple things that you can talk to if you get close and hit the right button. Nothing too exciting. The shader in question that I'm writing now is being applied to the player's draw event. So at the beginning of the player's draw event, you set the shader, you figure out what sprite you're going to draw, which is this whole thing here, and then at the end of the player's draw event, you unset the shader. So getting back to business, a common effect that you might want to use, and I've used this in some shader demonstration videos in the past, is something like color inversion. Let's say, to invert a color, you would subtract the red, green, and blue color values of the particular color from 1. In other words, you can say color is going to equal a vec4 of 1.0 minus color.red, 1.0 minus color.green, 1.0 minus color.blue, and 1 on the alpha channel. Actually, we'll go with the original alpha on the alpha channel, because then the completely transparent pixels around the edge of the duckling will actually be invisible and they won't just be ignored and colored black or whatever. So now we have a green and, well, a blue and light blue duck. There's a little bit of green on the staff. I don't know why I said green. Instead of the usual yellow and brown duck that we had. And this is a basic color inversion operation. It's pretty simple. It's one line of code. So there's no function call happening here. There's no function call being used. We are just doing this right here in the main function. We're doing this calculation right here in the main function. If you wanted to, you could define a function. So functions in shader languages are slightly different from functions in regular GML. If you were doing this in regular GML, you could say something like function, let's call it invert color, no equals, and some parentheses, and it can take an argument which can be original color, and then you could add some brackets, some curly braces. You could say new color is going to equal the vec4 of, let's just copy and paste this since I've already written that out. It can just be this calculation and use the original color as the parameter instead of whatever we were doing. And when we're done with that, we can return new color and call it a day. Since this is a shader language and this is not GML, this is obviously not going to work. There's a couple things about functions and statically typed languages that have to be accounted for. Shader languages, as you probably have realized by now, are statically typed, meaning that every piece of data has a type, which could be a floating point value or a vector 2 or a vector 4 or an integer or something like that. Firstly, to clean this up, this line is just a regular variable assignment, and that needs a type, so I need to call that a vector 4. I would run the game to show you the error message that you would get when you try to compile the shader, but honestly, GLSL ES shader compile errors are among the least helpful on the entire planet, so we probably won't really be getting much out of that. The function itself has a return type. It returns a value. If the function did not return a value, it would be void, the way the main function is. And the void return type would just indicate that the function does not have a return statement anywhere. This function does, this invert color function does, so it can't be void. The main function, on the other hand, doesn't return a value. Instead, it sets gl_frag color to whatever the output color is, or discards. Discarding is something you can also do. I don't know if I've talked about discarding yet. Anyway, at the end of the day, it doesn't return a value. In HLSL shaders, that is not actually the case. The main function in the fragment shader does return a value, as well as in the vertex shader. The main functions do return values. If you want more information on HLSL, which is Microsoft's shader language for Microsoft's DirectX graphics API, I made a video on that a few weeks ago, which you can go see. There will be a link on the screen right now. Anyway, invert color returns a value, so it has to have a return type. It returns a color, and colors are in the form of a vector 4, so it's going to return a vector 4. So we have to tell our code to expect a vector 4 as the return type from invert color. And lastly, the original color parameter is also a vector 4. And this needs to have we need to tell our code what type this variable is going to be, just the same way that we have to tell the code what type a variable is when you define it like this. So we can say vec4 original color, and this is somewhat like a variable definition anywhere else. So I can now run the game, and we're not actually calling this function anywhere, but it is going to compile, which I guess is kind of nice. Let's actually call that function. Let's call invert_color. Pass the original color as the parameter, and we can actually run the game now. And we're going to see we do indeed have our color inverted. Okay, that's pretty nice. So we've got our function defined up here, and we can just call it from wherever we want after that. Notice that I said after that, and that is because of a little quirk of the way that shader languages and some other computer languages are compiled. If instead of defining this invert color function up at the top of the shader, you instead decided to define it down at the bottom, and you tried to call the invert color function literally before the function was defined in the code, GML wouldn't care about that because functions are global and because it does a little bit of pre-processing and it knows which functions to look for, even if you haven't actually defined them yet in your code. As long as they exist somewhere else in your project, it'll be fine. When it comes to shaders, that is not the case. If I were to run the game now, we have a compile issue. We have a nice compile error down here at the bottom. Again, it's not very helpful because GLSL ES shader compile errors are among the least helpful things in the world. Line 13, there's something wrong with the invert color function being assigned to this. This is pointing to the wrong line of code, which I find endlessly hilarious. The actual error is on line 11 and not on line 13. In fact, there is nothing whatsoever on line 13. But we can see that it's complaining about the function invert color, which has quite clearly been defined at the bottom of the at the bottom of the shader. And that is because when the shader compiler reads the code from top to bottom, it resolves each symbol that it comes across in sequence, so every token, as it's called, every statement in the code, so varying vec2 text chord, that's fine because we're defining a varying variable that is of type vector2 called text chord. Void main here, that's fine because we're declaring a function. Vec4 color equals a varying variable which has already been defined, times a function which is part of the shader language, times gm_base texture, which is something that GameMaker gives it. All of these symbols, as they're called, all of these tokens already have meaning as the shader compiler reads your code, But when it gets to this line right here, invert color, this suddenly doesn't exist yet because it hasn't, there's nothing built into the shader language called invert color, and it has not found this function definition at the bottom yet. And then it just throws its hands in the air and complains and doesn't let you progress any farther than that because it doesn't know what to do. If you've ever written code in something like C or C++ before, you probably have run into this. This is one of the things that header files are meant to address in languages like C and C++. GLSL shaders and shaders in general don't really have header files. Strictly speaking, you can include code from other shaders, but it's not straightforward at all, and I will not be talking about that today. But what you can do is, one is obviously you can just define the function before you actually use it up here at the top of the shader, and then you'll be fine. That's what we had before, and it was fine. Or, since that is not always practical or not always very well organized, if you have multiple functions which sometimes call each other, that's not really going to be practical. What you can do is, instead of defining the entire function with the entire function body, you can simply tell the shader compiler that the function exists and can be used later on by saying vec4 invert color, open parentheses, vec4 original color, close parentheses, and then a semicolon. This is a function definition. Well, no, it's not. This is a function declaration, and all it does is tell the shader compiler that this symbol here, this function, does exist and you can use it, and it tells it what type it returns so that you can assign it to a variable, and it tells it what type the parameter is so you can pass color in as a parameter, and then at the bottom of the code you can actually give it its definition, which is the stuff that the actual function actually does, which is invert the color, evaluate the inverted color. So now if I were to run the game, this would be fine. We would be allowed to compile, and indeed the shader does what it's supposed to. It inverts the color. We have our blue duck instead of our yellow one. Again, if you're working with some languages like C or C++, this is something that you would probably put in a header file somewhere, and then include the header file. But we're not going to do that right here. We're just working with GLSL ES, and we want to keep things simple, so we're just going to declare the function at the top. Again, this isn't something you have to do. Obviously, this function here, this invert color function, is pretty simple, and it doesn't call any other code, any other functions or anything like that, and it's perfectly safe to just declare and define at the top of the shader. But if you're writing a more complicated code, which maybe calls some other functions that you've written, you might want to think about doing that. By the way, and this doesn't have anything to do with anything, but the color inversion, since you're just subtracting all of the values from 1, is a non-destructive process. So if you ever wondered what happened if you inverted a color twice, so if you were to call this function twice, we would have the same color that we started out with. We have our regular yellow duck back instead of the blue and cayenne duck, which I think is pretty neat.
Hey.
Again, that doesn't have anything to do with anything. I just thought that was a cool thing to point out for anyone who has not thought of it yet. And also, I guess it illustrates code reuse, since it's calling the function twice instead of having to do this whole thing twice. Let's see, what else is there? So, one, because I know this is probably going to bother someone, you can do this all in one line. You can simply return the result of this operation instead of saving it to a variable and then returning the variable. This is I generally would prefer to do this because it's slightly less code and it's slightly nicer looking. Same thing happens. We have our color inverted duck. That is also going to factor into the subject of another video that I'm hoping to have done by today. Possibly next week, but hopefully today. Anyway, this function here returns a value. It doesn't actually do anything to the original color. Original color is kind of not important once it has its values checked and it does something with those values. The result of this calculation is returned as a new vector4 and assigned to the color variable, and it replaces whatever was already there. If you were to instead say something like invert color, the shader should let me compile this, but we're going to see that nothing's actually going to happen. Yeah, the shader compiles, but nothing happens. We have our regularly colored duckling, yellow, no blue colors. And that is because color is not actually changed when it goes into the shader. I am going to define a new function, and I'm going to call it vec4 invert color. Let's call it something else. Let's call it invert color by myself, and it can do very much the same thing. It'll take a vec for original color, and instead of returning a vector 4, we are instead going to say, let's say original color dot r is going to equal 1.0 minus original. I have that copied, right? So I can just paste it. Original color dot r, original color dot blue. It should be green next. Equals 1.0 minus original color dot green, and original color dot blue equals 1.0 minus original color dot blue. We can call this instead. This is actually modifying the original color value that is passed in as a parameter, and we can try to call that instead of this version. I'm going to need to declare this at the top, aren't I? I don't need to. Again, I could just define this function at the top of the shader, but let's pretend to be good computer programmers today and declare the functions at the top of the shader. It looks cool, if nothing else. So I can run this, and it is going to complain about something on line 26. Oh, that's right. There is no return here. That needs to be void. We can't have a vector 4 function which actually doesn't return anything, because then the shader compiler will say, hey, we need a value here, and we don't have a value to give it. Let's update the function definition also. So the shader compilers, but nothing happens as before, even though we are calling the invert color by myself function down here, and it is indeed modifying the original value, and that is because pass by reference is a bit of a funny thing in shaders. Usually when you pass a value to a function, when you pass a vector 4 or a floating point or an integer or something to a function, you are passing the value instead. And this original color value down here as a parameter is not actually the same variable that you're passing in. It's just receiving the values. Sometimes that's fine, as you saw earlier in the invert color function that we wrote first. You don't actually need the original vector 4 structure. All you really need are the values that it contains, because you're just acting upon the values. You're not trying to change them or anything. If you wanted to change the original variable, and I realize this is something that you might not think of doing or really want to do if you come from a GML or JavaScript background. If the word pointer is something that keeps you awake at night, this might be something that you don't really want to do. But in shaders, you can choose to pass a variable to a function by reference instead of by value. By value being the default behavior. Fortunately, you don't really have to do much to your shader code in order to do this. If you're writing code in C and you wanted to pass a parameter by reference, then you would have to do all sorts of crazy, like, dereferencing nonsense and the arrow operator if you didn't want, like, your code to segfault in random places. All you have to do to tell GLSL ES that you want to pass a value by reference is add in out to the parameter in front of the vector 4, and all this does is it notifies the shader that this value here that you're passing in is copy the reference instead of the actual values. And of course, up here in the function definition in out vec4 original color, just so that the just so that the shader compiler knows that this exists, and these are the values that it takes as arguments. And we can run the game now, and the color will indeed be inverted. The red, green, and blue will be inverted. And that is because when you pass the color variable into this function, you are copying a reference to the actual color struct. And when you modify the values of the color variable inside the function, you are indeed modifying the original values, and not just a copy. And that's good. You don't have to do anything dumb like use the arrow operator for all of the in place of all the dot operators or anything like that. And I definitely appreciate that. Dealing with pointers in C and C++ is a pain in the neck. So in addition to in-out, and I'm not going to spend too much time on this because honestly I don't really care about these things, but in addition to the keyword in-out, to notify the shader compiler that you're passing something as a reference both into the function and that it is supposed to be preserved when it comes out of the function. There is also in and out as individual keywords. There may be situations in shader code where you actually want this, where you want to be able to pass a value into a function by reference, but like not do anything with that information when you leave the function. I don't know. I've never found any use for in and out as individual parameters. I always just use in out. Maybe there exists a situation where you'd want just one, where you would want just one of those attributes on this variable, but I was trying to avoid saying the word attribute because that's what these things are in the vertex shader. No, it doesn't have anything to do with that. I'm just using that as a word to describe this variable. Anyway, that exists virtually all the time when you're trying to pass something by reference in a function in a shader. You're just going to want to use in out. Okay, so that is it for shader functions. They're pretty handy. They can save you a lot of time. If you're used to dynamic languages like GML or JavaScript or something like that, it may take a little bit of getting used to having to type all of your function return types and all of your function arguments and everything like that. But I don't think it's too bad. And this is indeed a good thing to know about. In previous shader videos that I've made, if you want to, you can indeed make things like the billboard function, the billboard code, its own function in the shader, or the tune shader effect, lighting effects in the shader, their own functions. You may find that makes it easier to organize your code, and especially with the lighting functions, you may find that it makes it easier to combine that with other effects, such as the tune shader, because I believe in those videos on tune shaders, everything was hard-coded. Everything was just like there was a hard-coded spotlight or something like that. Okay, by the way, one thing that you are not allowed to do in shaders with functions that you are allowed to do in many other programming languages, and by that I mean most programming languages, is recursion. You are not allowed to have a function call itself in any way, shape, or form. This is how the shader languages are designed. Actually, can you do it in HLSL? I would be very surprised if you can do recursion in HLSL. Oh, can you actually? This is a very old version of HLSL, but okay, you can't do it in HLSL. Good to know. Anyway, recursion is not a thing you can do. That's just a limitation of the languages. Fortunately, it's not something that you really find yourself wanting to do very often, as far as I know, in computer graphics shader languages, as often as you would want to do it in something like CPU programming to work out an algorithm or something, AI of some sort. I imagine that even if it was allowed, it would be kind of inefficient due to the way that graphics cards are optimized to do things. But nevertheless, that's that. I am going to end this off. If you want the code for this, there's not a lot of it. There is usually not a lot of code in these videos. But if you want it, let's see, GitHub. Are you going to identify these changes that I made? Alright, GitHub desktop is not responding, but there will be a link to a GitHub repository in the video description containing this project that you can use and mess around with and do whatever with. I have a Patreon, so if you want to contribute towards these videos being made, there are links to those in all the usual places. Otherwise, I try to post about 2 of these videos a week, one tutorial, and one let's make a tower defense game, week by week. I've been very inconsistent with getting those up, but hopefully I should have a little bit more time now, so it should hopefully be happening a little bit more regularly now. Subscribe for those if you're interested. I hope you all enjoyed that, and I will see you all later. Special thanks to Emily Koyo, Posho, Edward Holt, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page in the video description to join the fun.